Hello everyone, my name is Siddhi Madane and I am engineering student of Electronics and Telecommunication Engineering pursuing from Shivnagar Vidya Prasarak Mandal College of Engineering, Malegaon, Baramati. I would like to thank Emertxe Information Technology Private Limited for giving us opportunity of embedded system internship and making a project on washing machine simulation using PixSim Lab. This project is made by me and my friend Madhura Pawar. Table of content that I have used: Introduction, Embedded C, Microcontroller Selection, Software Requirements and Hardware Peripherals. Things that I have learned during this internship: Introduction to C language, conditions, loops, operators, strings, pointers. Introduction to embedded C, basic of embedded C, introduction to microcontroller and microprocessors. Project implementation, implementation using MPLAB X IDE and PixSim Lab. Introduction of washing machine. Washing machines have become an essential part of our daily lives, revolutionizing the way we wash our clothes. What was once time consuming and physically demanding work has now become easier thanks to these modern marvels of technology, from the early days of manual labors to today's smart devices that can practically wash clothes for you. What is an embedded system? It is a combination of hardware and software programming using embedded C. Examples of embedded system machines is washing machines, AC, refrigerator, etc. Types of embedded C. Basically, type of embedded system are two types: ones which are functional requirements based and others on the performance of the microcontroller. Those which are dependent on the functional requirements are real-time, standalone, network, mobiles, embedded systems, and other based on the performance of microcontroller are small scale, medium scales, and sophisticated. Basic of embedded C. An embedded system is a microprocessor based computer hardware system with software that is designed to perform dedicated functions either as an independent system or as a part of large system. At the core is an integrated circuit designed to carry out computations for real-time operations. Here is the block diagram of embedded system: sensors, analog to digital converter, processors and ASCII, then digital to analog, actuator and memory to perform specific tasks. Compilers are microprocessors and microcontrollers. In microcontroller, IC capable of being programmed to perform a task has simple design architectures. All components are available in a single chip. In microprocessor, IC capable of being programmed to perform any task, comparatively complex design architectures, peripherals need to be interfaced. Keywords in C language. There are 32 keywords in C language. These keywords have specific meanings and functionalities within the C programming language. Data types. There are three types of data types: primary data type, derived data type, and user-defined data type. Data types are used for declaring the type of variable in C programming languages. Operators in C. There are many operators used in C language, that is unary operator, arithmetic operator, relational operator, logical operator, bitwise operator, assignment operator, and last ternary or conditional operator. Operator plays a fundamental role in programming language, enable a data manipulation. Project requirements: simulating a washing machine using PixSimLab. Microcontroller use in this, that is PIC16F877A. Software use MPLAB X IDE, then PixSimLab, and another is X8 compiler. MPLAB X IDE. MPLAB is a proprietary freeware IDE. It is developed by Microchip Technologies. It is being used for programming and development purpose for embedded system. The versions which we have used for our project is V5.35. Then PixSimLab. Regarding this, is a proprietary free software for simulation of various microcontroller board available. It can simulate most of the widely used microcontrollers boards like PIC, Arduino, STM32, ESP32, etc. MPLAB X8 compiler, a powerful C compiler that translates high-level code into efficient machine-level instruction for PIC16F877 microcontroller.
Hello everyone, myself Madhura Pawar. I am going to explain next slide, that is component used in microcontroller or in this project. Here we used microcontroller PIC16F877A. It is an excellent choice for washing machine program. It contains 8-bit CMOS flash based RISC CPU, 8 KB program memory, 368 bytes of RAM, 3 timers, digital input pins, then 10-bit ADC, that is analog digital converter, and 200 nanosecond instruction execution. The block diagram of a microcontroller, it contains display that we called CLCD. It shows the washing machine status, then buzzer, motor, power on, pause and stop, navigation, and door status. In this project we use switch number 5 for power on. To pause or stop washing machine function, we use switch 6. For navigation, means to assign a function to washing machine, we use switch 4, and to check the door status we use switch 1. In CLCD we see the washing machine status when it display all things. Then buzzer is used when it is used to give alert when door is open, and motor, that is for washing machine. First is a timer. In PIC16F877A, it has 3 timers which can be used as a timer counter or PWM. It has a following features: tick, that is based on the instruction cycle. Then resolution, it is a length of a timer register. Then quantum, that is a period of a tick. Then scaling, it is a method where we can delay the process of going into ISR if required. Then CLCD, it is a dot matrix liquid crystal display. It can be used to display the characteristic alphabets, numbers, emojis, etc. It is available in different modules. It has 16 columns and 2 rows. In this project we use 16 columns and 4 rows CLCD. It operates on 4-bit mode or 8-bit mode with microcontroller or microprocessor. It has following pins. Next is buzzer. The buzzer is a in washing machine is used to keep in the back of the washing cycle. The buzzer arm activates when the door of a washing machine is back opened represented by clicking the RB0 button. It also activates for 3 seconds when the washing is completed successfully. That means when washing machine completes its function, buzzers on. Next is a fan. In this project we used fan to represent the working of washing machine. The spin of the motor starts when any washing mode is selected and continue till the end of the washing cycle. The motor stops when it detects the door is open and starts when door is closed. Conclusion of the washing machine. The washing machine simulation is Pixim Lab. Using Pixim Lab serves as a effective tool for learning and applying concepts in an embedded system. It offered a hand-on experience that complements theoretical knowledge and provides a foundation for further exploration in the field of automation and control system. Next, we are going to learn about the working of a project. This project involves the design and the implementing the core logic for a modern washing machine, focusing on efficient control of a various wash cycle, motor operations, water levels, and safety features. Utilizing the power of embedded C, we aim to create a relatable and user-friendly system that simulates the real-world functionality of an automated washing appliances. Next, we will see the working of project. We load a file first. Here first we use a PIX Genius board and microcontroller, that is a PIX16 F877A. When we open a file, we see press key 5 to power on washing machine. As I first said, we use key 5 for turn on the washing machine. It is powering on the washing machine. Now we again to press key 5 to it. Now it shows the programs of washing programs. To select the washing program, we use key number 4. Here we select delicates. To select delicates, to scroll down we use key 4, and to select it we need to press it long time for long. long press for now to water level. Now we can see the water level. Same to select, to scroll down we use key 4, and to select it we need to press it long for long time. Here I select high water level. Now we see switches, two switches. First one is to start and second is to stop. When we start, the fan starts. To stop, when we press switch number 4, sorry, switch 6, then the washing machine come back, it come back to the functions. Okay, now I press key switch number 5, that is RB4. The washing machine starts. Program is delicate and it takes time for 31 seconds. Okay, here we can see if I press RB0, that is switch number 1, that means door opens. Okay, we see if we press RB0, the here we can see on CLCD it shows door is open, please close it. If we unpress the switch, it stops and function carry on. When the program is completed, we can see there is code that it shows program is closed, please take off the clothes, and that's it, and it restarts. Now I will show you the project program. In MPLAB XIDE we perform the program, and in MPLAB IPE it is a compiler we used. Here you can see In header files, we created a separate header file for each component. For real CLCD, for digital key, main and timer. Same in a source file, we created separate files for each component. CLCD, digital keypad, main. In main we can see we are given the programs or functions of washing machine in array format, and also the water levels in array format. To print on CLCD, we used CLCD print keyword. During my time at Emertxe, I had the opportunity to work on an excellent embedded system project, developing a smart washing machine program and control system using embedded C. Thank you for this experience.